Hello, I'm Dr. Ron England, and welcome to Python Programming for Engineers. This is Lecture 7, and in Lecture 7, we're going to actually do a linear regression, and we're going to look at some of the other libraries. The only library I think that you've actually seen is a little bit of PyPlot, and you might have seen you've seen a lot of NumPy. So we're going to kind of get into some of these other libraries that are available to you and show you how to start working some real practical problems. So the first thing that I'm going to do is, the whole point of this is I'm going to do a linear regression. And the linear regression, because I want to demonstrate it, I'm going to take data in from a file, and I'm going to take two columns of that file. Well, actually, I'm going to do two files. And I'm going to take the columns from those files, and I'm going to regress one versus the other. And what I'm going to do a regression is, for Daytona Beach, because this is Daytona State College, I'm going to take the minimum temperature and the maximum temperature for every day for the year 2017, and I'm going to look to see if there is an actual equation that I can use that you can estimate the maximum temperature for the day from the minimum temperature. So with that all said, let's get started. Okay, so the first thing I want to use is the library called Pandas, P-A-N-D-A-S. This is going to, if you're doing real practical programming with lots of data, you must have Pandas. So first, let's look at the data. Now, I downloaded this data off the internet. It's from the meteorological data, and I have two files here, Daytona 2017 max temp. And if you look at this, what it does is for every day in the year 2017, it's got the maximum temperature for that day. And if you notice, one day in here, it's actually got a negative 99. That was there's day negative 99.9. That's the day that they actually did not collect the data on January the 25th. And so there's a bad piece of data in there, which, by the way, is important because we're going to have to figure out how to remove that. And no, I'm not going to just take it out of the text file. All right, so there's your data for max temp. And if I looked at the data for min temp, which is going to look pretty much the same. There's the dates and the data. All right, well, with that all out of the way, and now knowing that you've got this in files, first thing that we're going to do is we're going to go ahead and use the Pandas library. Now, I know if you're in the class, the Programming for Engineers class, you're going to go, well, there's lots of these libraries. How am I going to know what libraries I'm going to need to do what? Well, here's how you're going to know. You're going to research how to solve problems. And when you're solving problems, you're going to research that there's actually libraries available that will help you solve them. This is just part of being an engineer, is knowing how to use the right libraries. If you can use Python, Python is going to make all of this incredibly simple. So let's make it incredibly simple. So the first thing I'm going to do is I'm going to read that file that I just showed you. And inside the Pandas library, there's a read underscore CSV method. So you're going to be able to use that method to bring in that data. Boom. Now, what's going to happen first, it's going to say, oh my gosh, I couldn't find the file. Well, the reason it couldn't find the file is because the file is in a directory that is not the current directory. Important that I showed you that, so let's show you how to get to the current directory. Now, if you're in Spider, this is easy to do. You've got this File Explorer here, and all you've got to simply do is in the File Explorer, find the specific directory that has the file that you're looking for, and it's in this directory right here through the File Explorer. There's a bunch of keys for you to go up directory, you can maneuver, and now I can go back to this and I can go boom, min data, and this time it's going to read that CSV file. Now, other errors could occur, but part of what you need to do is be able to figure out how to get through those different types of errors. And what I could do is I could print out min data, so I can control enter that, and it's just going to throw that in those entire 365 up to the screen. But if you notice what it actually does the first 30, and then it does the last 30. So it doesn't show, if it's a ton of data, it's not going to just blap your whole screen. Okay, so good. That's actually important. All right, let's do the same thing with the maximum temperatures. So I'm going to do max data and bring that in. Now, one way that's probably the best way to start looking at this data is to use the Variable Explorer. And that's important for you too. You need to know how to use the Variable Explorer because first, there's some useful information in this Variable Explorer. there's your min data and there's your max data. And what I did was when I had Pandas read the file in, I had it read it into a variable min data, and I had it read this one into a variable max data. And the data is it's an object, and the type of object that it is a data frame. Okay, and a data frame is simply a structure that's designed to hold data. If I look at this by double clicking on it, I can actually see there's my values. They're all right there, and I can scroll down and you'll find that there's actually 364, but there's 364 because it starts at 0. So you got 365 days of data. There they all are. Okay, and so I can double click to get that, and I can also look to see that the values have column names. Now, of course, if you don't have the Variable Explorer right there available to you, well, you're still not, you still got things that you can do, because the Pandas library, which defines the data frame has lots of methods. Remember, a method is a function that works on an object. The data frame is a type of object, so therefore I could say, let's describe the min data. If I bring that up and hit Control Enter, I come down here into my console window, and it's going to say, there are the columns. And remember, the columns did have labels on it, and it says there's 365 pieces of data, the mean of the data, the standard deviation. So it gives you some statistics, but it's really the statistics because you've got year, month, day. Well, the only one that really has meaningful statistics is the min temp, which is the column that has the minimum temperatures. Okay, so, or I could do something else here. I could say min data, and I could call the head function, which is also going to give me information, which is going to show me the headers, COPID, year, month, day, min, temp, and show me the first 5 pieces of data that are there, which should be enough for me to figure out the format of the data. That is really kind of neat. You've got this capability to do these types of things. But we're going to talk about 2 functions that will be absolutely invaluable to you, and I am not going to cover every single possibility of these 2 functions because these are insanely powerful functions, and you will want to investigate the lock and the LOC and the ILOC methods for a data frame, all the different things that it can do. And it's got a very specific type of structure that you use to do this. So first thing that I want to do is I want to go ahead and bring in, from those 2 pieces of data, I want to separate out the one column that is the min temp and the one column that is the max temp, and I want to define them. I want to put them into their own variables. So to do this, I'm going to call the iloc method of the data frame on the min data. So min data is an object of type data frame which has the method ILOC. And I'm going to call that function. And look at those arguments. They're really bizarre. A colon, comma, 4. What that means is it's row, comma, column. So what I'm saying is I want to bring in all the rows, and I want to bring in the basically, in this case, the 5th column because it indexes at 0. So 0 is the first column. Column 4 is actually the 5th column, which is the minimum temperature. And I'm going to do that for both min and max. If I do that, there's my Control Enter. Boom! Look at that. I've now got a max temps and a min temps. And now if I look at, let's say, min temps, it's the minimum temperatures. Okay? And notice something that I've got right here that is really kind of useful as if I scroll through. When I got to that value there, which had the negative 99.9, which was the missing piece of data on the minimum temperatures, it showed up in red because it was way out of the range of the other pieces of data. And it points out to me that if I'm going to do any type of analysis with this, I got to get rid of it. Well, if I do the same thing on max temps, I'm also going to note that, well, if they missed the minimum temperature on the 24th of January, they also missed the maximum temperature on the 24th of January. And I'm probably going to have to get rid of that piece of data. Before I get rid of that piece of data, I'm just going to show you another piece of the ILOC function for the temp. So if I wanted to bring back a single temperature, look at my format here. I have ILOC method with, in this case, 100, 4. Well, the 100, 4, what that's going to do is it's going to bring back row 100, column 4. But if I go like that, A temp is over here. If I go to there, that's the column that's the row that's indexed at 100, and the 4th column, which is the minimum temperature, or the 5th column at the 4th indexed column. and there it is. That's what I can get. So I have the ability to isolate a single piece of data, and I could have actually isolated two. I could have gone like that and put in, in this case, the A temp will give me back 100 and 101. So I've got two of them there, and that gives you a lot of capability. Now, the ILOC and the LOC are, again, insanely powerful. There are so many things that you can do with this, and there's no way I'm going to cover them all. You can do the research in the documentation, and there's a ton of great YouTube videos on how to parse the data all these different ways. If you're going to be working with data, you need to work through it, because there's literally hardly anything you cannot do with data using those two functions that are part of the Pandas library. For that matter, the Pandas library is just a monster at being able to manipulate data. Now, let's do one of those great things that I need to do, that I want to do with this data. And if you look at this line, it says min data is equal to min data, then in brackets, min data.iloc, colon, comma, 4, not equal to negative 99.9. Now, you're going, what does that do? Well, what that does is it's going to replace the current min data, which is, by the way, a series object, with the series that excludes the negative 99.9, the data that's negative 99.9. So in other words, it's going to replace it with everything that is not equal to negative 99.9, which is what this inner part does right here. So again, not going over every single nuance of the grammar of how the Pandas and that works, right off the bat I can say, wow, I can create conditionals, ifs, conditionals, things that you use in if-then statements, on series that will either include or exclude or allow me to do all sorts of different kinds of conditions and define the data that I want to use in my analysis. And I'm going to do it both for min data and for max data. So what this is going to do, and I want you to first look and up here to see, this has currently got 365. This has got currently 365 in min temps and max temps. I'm going to go ahead and execute these two right here. And now the values of max data and min data are 364. And now I'll just go ahead and redefine the min temps and the max temps from the min data and the max data, because I got rid of that negative 99.9. And I could have done this on the series. I could have done, what I did is I did it on the data frame. I may leave it to you as an exercise to figure out how to do it on other series, but I've got plenty of diabolical problems that you'll need to solve. But let's go ahead and redo the min temps and max temps. Now there's 364 pieces of data. All right. I've got a series that contains the minimum temperatures. I got a series that contains the maximum temperatures. Well, the first thing that I might want to do is I might simply want to plot those against each other to see if there's any possibility of correlating them against each other. So let's do that. Now, for that one, I'm going to use pyplot. So I'm going to import the matplotlib.pyplot as PLT, and I'm just going to do a scatter plot of the two. And the scatter plot shows that, yeah, they do look like there's some sort of rough correlation there, that I probably could do it. And it probably isn't the best fit on a standard linear regression on a line, but I'm not going to get more complex than a line today. So let's do a linear regression. And so what I'm going to do here is I'm going to use SciPy, and I'm going to use the stats routines from the library SciPy. All right, so right off the bat, I'm importing the stats, and boom, now I can go ahead and I can do a linear regression. Well, if you haven't had statistics, what's a linear regression? A linear regression is the attempt to fit this data to a line that has the format. This is a standard linear regression, nothing fancy. It's going to have it's going to be the equation y equals mx plus b, or as you might also know it as, is y equals intercept plus slope times independent variable. Okay, y equals mx plus b. Anybody who's out algebra is at least going to understand that. But I want to find the m and the b, the slope and the intercept. Well, the stats.linregress, in other words, I brought in stats from the SciPy, has the ability to do just that. And again, anybody who's familiar with Python is going to go, but there's a lot of ways to do this. Yeah, well, that's not the ways I'm using it. I'm going to use this one right here that takes the linregress function, which takes the two dependent and independent variables that I want to regress against each other, and it calculates the slope, the intercept, the R, the probability, the standard error. All those are going to get populated in this one thing. And notice this has got a unique index, a unique format. I'm actually setting 5 variables with 1 equals because the stats linregress brings all those back. One of the great capabilities here. So now I'm going to do it in Control Enter, and boom, it works. And notice up here in my variable explorer, I've now got the P, the R, the slope, the standard error, and the intercept. Well, the two that I'm concerned with are intercept and slope. Now, you would, if you're doing a traditional statistical analysis, you're going to be looking at the standard error and you're going to be looking at the R squared value to tell you how good that fit is. But let me tell you the best way to know how good a fit to a line is. Look at it. Plot it. Look to see if it actually makes sense. So let's do just that, and let's do something a little bit different because, of course, I want to demonstrate as much as possible that you can do here. Let's bring in the NumPy, which we've worked with before. Let's import NumPy here. And let's go ahead. And now I'm going to create a variable using the aRange function. And what the aRange function is going to do is it's going to say, let's just set V to be an array that runs between 35 and 95 steps of 5. Okay, so if I do this, boom, and now it's there. And you know what? Let's look at that good old V there. Well, that was kind of nice. I don't have to do a bunch of funky stuff to get those variables. Well, why do I care? Why do I even want this 35 through 90? Well, I want that because I want to plot it as a function, and I know what the function's going to be. It's intercept plus slope times V. So now I've got the plot from Matplotlib, and if you start looking at the documentation of the Matplotlib library or PyPlot, you're going to go, holy smokes, this thing does a lot of stuff. So what I'm going to do now is I'm going to say, I'm going to use the plot function of PyPlot, where I'm going to say, take the V, which by the way is an array, you saw that, of floats, because I looked at V, and then let's put in the equation. So what I'm doing is saying is V is essentially X. Intercept plus slope times V is essentially Y. So I want to plot the X versus the Y by using the actual equation, and I want to do it, and I want the symbol to be blue squares. And that's what BS actually stands for in this case. Not that it's that's what it is. And I also want to plot min temps and max temps, and I want to do that with green triangles. Well, the reason I want to plot the min temps and the max temps on the same plot is so you can see how well they look together, not with one and separately from the other one. And the plot function allows you to do multiple series of different types of variables all on the same plot. So if I take this whole thing here and I hit Control Enter, booyah, there it is. You've got the all those little green triangles are the actual data that you started with. The blue squares are right there, and you've got the ability to see that, you know, that doesn't look terribly bad. It does seem to curve off here at the end. That could be an anomaly of just the data set that we're using. So how would you test this? Well, you'd use more data sets. But look at what I've done. And I did this in 20 minutes. This didn't take me a ton of time. I brought in 2 large data sets. I parsed them to get the columns that I wanted to compare against each other. I threw out the variables that I knew were going to be bad because there was bad missing data in the thing. I went ahead and did a linear regression of it and got the slope and the intercept. And then I went ahead and turned around and plotted the values against each other step by step by step. Now, again, I didn't write a program to do all this, but I actually used the Python in this mode of being able to run each line and actually work with each line. But for engineering problem solving, this is amazingly powerful. So I want you to I want you to research the capability of Pandas for things that you might need to do. Look at what SciPy can do, look at what NumPy can do, and look at what PyPlot can do. There's a lot of capability. There's really good documentation out there, and I don't need to be shooting videos on exactly all these. I'm all in this about engineering problem solving and how to target, how to solve the problem the best way using these tools. And this is a great way to come up with, wow, I can actually do a fairly decent estimate now of the maximum temperature given the minimum temperature. Pretty neat stuff. Thank you very much, and good programming.